Right now, your smoke alarm goes off when you cook bacon. Your modern home fills with smoke from one small pan. But 600 years ago, the Haudenosaunee people built something that will blow your mind. Picture this, a building longer than a football field. 400 feet of wooden structure stretching across the forest floor. Inside, 60 people live together. 12 fires burn at the same time, not just for cooking, but for warmth, light, and daily life. And here's the crazy part. Zero smoke in the living spaces. While we struggle with one smoking pan, they mastered smoke from 12 fires in a single building. See how the early morning mist rises over the ancient village in what we now call New York State. Massive longhouses stretch across the cleared forest areas like wooden ships anchored on dry land. Smoke curls up from perfectly placed holes in the bark roofs, but step inside and the air above your head is crystal clear. This isn't just about smoke control. The same system that kept the air clean also created mosquito-free zones. The Haudenosaunee didn't just solve one problem, they solved two problems with one brilliant design. The people who created this were the Haudenosaunee Confederacy, 6 nations working together: the Mohawk, Oneida, Onondaga, Cayuga, Seneca, and Tuscarora. These master builders lived in the thick forests of northeastern North America from 1100 to 1800 CE. They faced challenges that would break modern people. Go back to those dense forests where clouds of mosquitoes swarmed every summer. Feel the bite of winter cold that dropped to 40 degrees below zero. Watch as families needed constant fires just to survive. The problem was huge. How do you keep fires burning without choking on smoke? How do you stay warm without getting eaten alive by bugs? The Haudenosaunee looked at these problems and created something amazing. They built ventilation systems so smart that modern engineers are just now figuring out how they worked. Here's what makes this even more incredible. Military survival training programs now study these techniques. Special forces instructors teach soldiers to build shelters using principles the Haudenosaunee perfected centuries ago. Why? Because when your life depends on it, ancient wisdom beats modern gear. Look at the interior of a working longhouse. Families gather around their individual fires, preparing food and staying warm. Above their heads, the air stays clear and breathable. Children play safely while multiple fires burn just feet away. The smoke rises smoothly through carefully designed openings in the roof. Watch skilled hands adjust movable bark flaps on the roof. These aren't just holes, they're precision-engineered vents that respond to wind direction. When storms come, the flaps close automatically. When mosquitoes swarm outside, the inside stays bug-free. Scientists have tested these old methods against modern HVAC systems. The results shocked them. The traditional approach worked better than many modern ventilation systems. It used zero electricity, made no noise, and created perfectly comfortable living spaces. Stand next to one of these longhouses on a summer evening. Outside, mosquitoes form thick clouds that can drive animals crazy. Step through the bark doorway, and the bugs disappear. The same airflow that carries smoke away also creates invisible barriers that insects can't cross. Modern eco-architects now pay thousands of dollars to learn these techniques. Survival experts consider this knowledge essential for anyone serious about wilderness skills. The principles work just as well today as they did 600 years ago. Enter a world where families of 20 or more relatives live together in harmony. See the grandmother directing household activities while smoke from her fire rises straight up through the roof opening. Feel the comfortable temperature maintained without thermostats or electric heaters. The secret wasn't just in the design, it was in understanding how air moves naturally. The Haudenosaunee became masters of air pressure, wind patterns, and thermal dynamics. They created positive pressure zones that pushed smoke upward, while drawing fresh air through lower openings. Watch the magic happen as evening approaches. Fires glow brighter for cooking and warmth. Smoke streams rise like ghostly ribbons through the roof holes. The air inside stays fresh and clean. Families gather for stories and shared meals in complete comfort. This wasn't luck or accident. Archaeological evidence shows these techniques developed over 700 years of testing and improvement. Each generation of builders added refinements. Master craftsmen trained apprentices in secrets passed down through centuries. Think about what this means for you today. When modern power fails, these techniques still work. When expensive HVAC systems break down, these methods keep running. When you need emergency shelter, these principles can save your life. The contrast is stunning. Step outside the longhouse into the mosquito-swarmed forest. Feel the insects immediately attack any exposed skin, duck back inside, and they vanish. The same system managing smoke also creates a natural pest control barrier. Military instructors teach these methods because they work under extreme conditions. Survival schools include longhouse principles in their advanced courses. Emergency preparedness experts recommend understanding these techniques. Travel back to when skilled people solved problems with intelligence instead of electricity. See weathered hands working with stone tools and bark materials. Watch as they create solutions we're still trying to match with modern technology. By the end of this video, you'll know exactly how to build this system yourself. You'll understand the science behind the design. You'll have the knowledge to create smoke-free, mosquito-free living spaces using nothing but natural materials and ancient wisdom. But to understand how the Haudenosaunee developed this engineering marvel, we need to step back and explore the incredible culture that produced some of history's most sophisticated architects, people who built democratic governments and revolutionary buildings centuries before Europeans arrived on their shores. Meet the people who solved problems we still struggle with today. The Haudenosaunee weren't just skilled builders, they were brilliant innovators who created one of the world's first working democracies while developing revolutionary architecture. The Haudenosaunee Confederacy was a government that worked 400 years before America even existed. Think about that. While Europe was ruled by kings and queens, these 6 nations, the Mohawk, Oneida, Onondaga, Cayuga, Seneca, and Tuscarora, built a democratic system so advanced that America's founding fathers studied it when writing the Constitution. Picture the vast northeastern forest stretching from what we now call New York to Ontario. Dense woodlands filled with towering oaks, maples, and pines. This was Haudenosaunee territory, a landscape that demanded both respect and skill to survive. Watch as the seasons change across this challenging environment. Spring brings flooding rivers and thick mud. Summer explodes with life, but also brings clouds of mosquitoes so dense they can drive animals mad. Fall offers harvest time, but winter follows with temperatures that can drop to 40 degrees below zero. The Haudenosaunee looked at these extreme conditions and said, "We can master this," and they did. Around 1142 CE, these nations came together under the Great Law of Peace, a constitution that created democratic principles centuries before European philosophers even dreamed of such ideas. The Great Law established a government with checks and balances, women's rights, and environmental protection laws that modern nations are still trying to match. See how this political genius connected to their building genius. The same people who created democratic government also revolutionized architecture. They understood that both politics and buildings needed systems that worked for everyone, in all conditions, for generations. Enter the world of Haudenosaunee environmental mastery. These people didn't just live in the forest, they managed entire ecosystems. They used controlled burning to create clearings and encourage certain plants. They tracked animal migration patterns and adjusted their building locations accordingly. Archaeological evidence shows they refined their longhouse designs over 700 years of continuous improvement. Each generation of builders added innovations. What started as simple wooden structures evolved into sophisticated climate-controlled environments that could house entire extended families in comfort. Travel back to around 1200 CE and watch a Haudenosaunee village being planned. Master builders don't just pick random spots. They study wind patterns, water drainage, and seasonal sun angles. They consider how smoke will move in different weather. They think about defense, but also about daily life for children, elders, and everyone in between. Feel the weight of survival pressure that drove their innovations. Imagine building for minus 40 degrees Fahrenheit, winters and mosquito-swarmed summers. Modern homes struggle with much milder challenges. The Haudenosaunee created buildings that had to work perfectly, or people died. Winter meant life-or-death engineering challenges. Families needed constant heat for months. Multiple fires had to burn safely inside wooden structures. Smoke had to be managed without losing precious warmth. Fresh air was essential, but every opening meant heat loss that could kill. Stand in the summer forest where mosquito clouds form moving walls of insects. Watch how they swarm around any warm-blooded creature. Now imagine designing buildings that keep these pests out while staying cool and comfortable inside. The Haudenosaunee solution wasn't just functional, it was brilliant. They created airflow systems that moved smoke up and out while creating invisible barriers mosquitoes couldn't cross. The same engineering that managed winter fires also controlled summer pests. Traditional knowledge among the Haudenosaunee was passed down through generations of master craftsmen. Young people didn't just watch and learn, they served formal apprenticeships that could last decades. Master builders guarded construction secrets like military commanders protect battle plans. See how knowledge flowed through Haudenosaunee society. Clan mothers held enormous power and influence. They could remove chiefs, control property, and make decisions about major construction projects. This wasn't just about politics, it was about ensuring the best engineering knowledge survived and improved. Watch skilled hands work with stone tools and natural materials. Every cut of bark, every placement of support posts, every angle of the roof was calculated based on generations of testing and refinement. These weren't random folk traditions, this was sophisticated engineering, passed down through centuries of apprenticeship. The oral tradition system was incredibly advanced. Stories weren't just entertainment, they were technical manuals encoded in memorable narratives. Construction techniques, seasonal timing, material selection, and problem-solving methods were all preserved in stories that could be remembered perfectly across generations. Listen to a master builder teaching an apprentice. The lesson sounds like storytelling, but it's actually advanced engineering education. When Grandmother Spider taught us to weave, she showed us how each thread must support the others. This story contains precise instructions for roof support systems that modern engineers study in universities. Archaeological evidence reveals the sophistication of their planning. Excavated village sites show longhouses positioned for optimal airflow. Post-hole patterns demonstrate mathematical precision in construction. Artifact distributions prove they understood advanced principles of physics and environmental science. Modern researchers are amazed by what they discover at Haudenosaunee sites. Village layouts that maximize natural heating and cooling, smoke management systems more efficient than many modern designs, construction techniques that created buildings lasting decades with minimal maintenance. Travel through time and see how their techniques evolved. Early longhouses from 1100 CE were impressive but simple. By 1400 CE, the same basic design had been refined into climate control masterpieces. By 1600 CE, Haudenosaunee buildings were so advanced that European visitors wrote detailed descriptions, trying to understand how they worked. The scale of their achievements becomes clear when you see entire villages. Some longhouses stretched longer than city blocks. Villages contained multiple enormous buildings, each housing 60+ people in comfort. The engineering challenge of ventilating these spaces was like designing modern shopping malls, except they did it with stone tools and natural materials. Picture winter mornings in a Haudenosaunee village. Smoke rises in perfect columns from dozens of roof openings. Despite sub-zero temperatures outside, families inside stay warm and comfortable. Children play safely while multiple fires burn. Elders work on crafts in clear, breathable air. See the summer evening scene. Outside, mosquito clouds swarm so thick they blur the forest view. Inside the longhouses, families gather for meals and storytelling in bug-free comfort. The same ventilation system that managed winter smoke creates summer pest barriers. The knowledge systems that created these marvels were incredibly sophisticated. Master builders trained for decades before they could direct major construction. They learned not just how to build, but why each technique worked. They understood the science behind their methods, even though they explained it through stories and oral traditions. Watch a construction project unfold. It's not just skilled labor, it's applied science. Workers know exactly how different bark types respond to weather. They understand wind dynamics and air pressure. They can predict how structures will behave in storms, floods, and extreme temperatures. The environmental challenges they faced were extraordinary. Dense forests meant limited cleared space for villages. Harsh winters demanded maximum efficiency from every building material. Summer pest populations could make entire areas uninhabitable without proper protection. Modern space habitat researchers study principles the Haudenosaunee perfected centuries ago. Creating closed-loop air systems, managing multiple heat sources, maintaining comfortable temperatures in extreme environments. These are the same challenges NASA faces when designing spacecraft and Mars habitats. Think about the intellectual achievement this represents. Without written language, universities, or modern tools, the Haudenosaunee created engineering solutions that modern technology struggles to match. They did it through patient observation, careful testing, and brilliant application of natural principles. The matrilineal clan system wasn't just social organisation, it was also an innovation engine. Women controlled major construction decisions and resource allocation. This meant buildings had to work for the people who actually lived in them every day. Practical functionality drove design choices, not just builder preferences. Archaeological findings continue to reveal new aspects of their sophistication. Recent excavations uncover evidence of even more advanced techniques. Construction methods that created natural air conditioning, smoke management systems with multiple backup options, building designs that adapted automatically to changing weather conditions. This rich cultural foundation and centuries of refinement produced architectural techniques so advanced that we're still discovering how they worked. Now, let's dive into the exact step-by-step methods these master builders used to create their remarkable ventilation systems. Now we get to the amazing part, exactly how the Haudenosaunee built their incredible ventilation systems. No nails, no metal, no electric tools, just precision engineering that worked better than many modern systems. Picture skilled hands working in the early morning forest. The master builders have studied this location for weeks, watching how wind moves through the trees and where water flows during storms. Every decision they make has been tested by generations of builders before them. The foundation framework starts with living trees whenever possible. Watch as builders select young saplings growing in perfect rows. These aren't just convenient, they're engineered anchor points. The living roots will keep the structure stable for decades, while the flexible trunks can bend with storms without breaking. See how they position the main posts exactly 4 to 5 feet apart. This isn't random spacing, it's calculated for optimal airflow and structural strength. Each post gets planted in a hole dug precisely 2 feet deep. The earth gets packed tight around each post using wooden tools and stone hammers. Feel the rough texture of the posts as workers strip away excess bark and shape each piece for its specific job. The corner posts are the thickest, these will bear the most weight. Interior posts are smaller but perfectly straight. Each piece is chosen for its role in the final design. The horizontal framework connects everything together like a wooden skeleton. Long poles stretch from post to post tied in place with leather strips or twisted bark rope. These aren't just supports, they're the foundation for the ventilation system that will control every breath of air inside the longhouse. Watch the mathematical precision as builders mark exactly where each smoke hole will go. Every 20 feet along the ridge, they place a marker. This spacing isn't accidental. It creates the perfect balance between smoke removal and structural strength. Too close together and the roof becomes weak. Too far apart and smoke builds up in dead zones. Travel back to early spring and watch the bark harvesting begin. Elm bark was chosen for specific thermal properties that modern science is just beginning to understand. The inner bark breathes like skin, allowing moisture to escape while keeping rain out. The outer bark provides waterproof protection that lasts for years. See how harvesters select the perfect trees. Young elms with smooth bark work best. The sap must be flowing. That's why spring is crucial. When sap moves through the tree, the bark peels off in large, flexible sheets that can be shaped and molded like natural building materials. The bark harvesting process is like peeling a giant orange. Workers make careful cuts with stone knives, following the natural lines of the tree. They start at the base and work upward, removing sheets that can be 8 feet long and 4 feet wide. Each piece gets rolled up immediately to prevent cracking. Watch skilled hands prepare the bark for installation. Each sheet gets soaked in water until it becomes flexible, then it's stretched and shaped while damp. The workers know exactly how much each piece will shrink as it dries, so they cut everything slightly oversized. The covering system works like overlapping scales on a fish. Starting at the bottom, each row of bark covers the edge of the row below it. Rain hits the upper pieces and runs down the outside, never finding a way through to the interior. It's waterproofing that doesn't need any modern materials. Feel the intelligence in every overlap pattern. The builders don't just slap bark onto the frame, they study how water moves and create paths that guide every drop away from the living spaces inside. The angles are calculated to work with gravity and wind patterns. Now comes the revolutionary part, the smoke hole engineering. Each opening gets positioned directly above where a fire pit will go. But it's not just a hole in the roof, it's a sophisticated ventilation system that controls airflow like a natural fan. See how builders cut each smoke hole to the perfect size? Too small and smoke backs up inside, too large and heat escapes too quickly in winter. The master builders know the exact proportions. Typically, About 3 feet across for each fire pit below, the ventilation flap innovation separates amateur builders from masters. Each smoke hole gets its own adjustable cover made from carefully selected bark. These aren't just lids, they're precision instruments that respond to changing weather conditions. Watch as workers create the hinges using twisted leather strips. The flaps must move easily but stay in position once adjusted. In strong winds, they can be secured completely closed. In gentle breezes, they open partially to control airflow. Feel the mechanical genius as each flap gets calibrated for its specific location. Flaps on the windward side work differently than those protected by trees. End flaps handle different air pressures than middle ones. Every single opening gets individually tuned. The airflow dynamics create something that seems impossible: positive pressure without electric fans. Here's how it works. Fires heat the air inside the longhouse. Hot air weighs less than cold air, so it rises naturally toward the smoke holes. As hot air escapes through the roof, it creates suction that pulls fresh air in through lower openings. Picture the invisible rivers of air flowing through the completed structure. Cool, fresh air enters through gaps between bark sheets near the ground. It warms up as it passes the fires, then rises in smooth columns toward the smoke holes. The system creates its own circulation without any moving parts. This isn't just smoke management, it's climate control. In summer, the system pulls hot air out and draws in cooler air from shaded areas around the building. In winter, the flaps adjust to keep more heat inside while still removing smoke and maintaining fresh air circulation. See how the pest control integration works its magic. Mosquitoes hate moving air and avoid smoky areas. The longhouse ventilation system creates both conditions simultaneously. Gentle air currents near the entrances discourage insects from entering, while strategic smoke patterns create invisible barriers they won't cross. Watch the seasonal adjustment protocols in action. Spring construction starts with all flaps partially open to handle damp conditions and varying temperatures. Summer settings maximize airflow to stay cool and bug-free. Fall adjustments prepare for winter heating needs. Winter configurations balance warmth retention with smoke removal. The system automatically adjusts to wind direction changes. When wind hits the flaps directly, they close partially, preventing downdrafts that could blow smoke back into the living areas. When wind comes from the side, the flaps open wider to take advantage of the increased suction effect. Feel the craftsmanship as workers install the final ventilation components. Each smoke hole gets a rim of specially prepared bark that channels water away during storms. The flaps attach with hinges that can survive years of weather and daily adjustments. Modern HVAC systems struggle to match this efficiency. Contemporary buildings use electric fans, complex ductwork, and computerized controls to achieve what the Haudenosaunee accomplished with natural materials and brilliant design. Their system runs completely silent, uses zero energy, and requires minimal maintenance. Picture the testing process as construction nears completion. Builders light small fires and watch how smoke moves through the system. They adjust flap positions and observe airflow patterns. Any problems get fixed immediately. There are no second chances when winter arrives. Military survival instructors now teach these principles because they work under extreme conditions. Special forces learn to create positive pressure ventilation using the same physics the Haudenosaunee mastered centuries ago. When modern equipment fails, these ancient techniques still function perfectly. See the cross-section view of the completed ventilation system in action. Smoke rises in perfect columns through each opening. Fresh air circulates smoothly throughout the living spaces. The temperature stays comfortable even with multiple fires burning. The air quality remains clean and breathable. Each flap gets individually calibrated for optimal performance. Master builders test every adjustment. They know exactly how far to open each cover for different wind conditions. They understand which flaps work together and which ones need independent control. Watch the incredible precision as builders fine-tune the system. A quarter-turn adjustment on one flap can redirect airflow throughout the entire structure. The master builders understand these relationships through years of training and practical experience. The interior views show the final result. Families living comfortably around their fires with crystal clear air above their heads. Children play safely while smoke streams upward through the precisely positioned openings. The ventilation system works so smoothly it becomes invisible. Contemporary eco-architects pay thousands of dollars to learn these principles. Modern green building projects attempt to recreate what the Haudenosaunee perfected using only natural materials and traditional knowledge. The physics haven't changed, hot air still rises, and pressure differentials still create air movement. Think about the intellectual achievement this represents. Without computers, mechanical engineers, or modern testing equipment, these builders created ventilation systems that automatically adjust to changing conditions. They understood air pressure dynamics, thermal physics, and fluid mechanics through careful observation and generations of experimentation. The system handles multiple variables simultaneously: outside temperature, wind speed, wind direction, interior heat load, humidity levels, and seasonal changes all get managed by the same elegantly simple design. Modern HVAC systems require complex sensors and computer controls to handle this many variables. See how the pest control elements integrate seamlessly with smoke management. The same air currents that carry smoke away also create movement patterns that insects avoid. The smoke itself acts as a natural repellent without compromising air quality for the human occupants. Picture the long-term durability of the system. The bark covering lasts for years with minimal maintenance. The wooden framework, properly installed, can survive decades of weather. The ventilation principles remain effective as long as the structure stands. Modern research validates what the Haudenosaunee knew through practical experience. Laboratory testing confirms that their ventilation systems achieve better air exchange rates than many contemporary designs. The natural materials provide superior humidity control and temperature regulation. Watch the seasonal maintenance routines that keep the system working perfectly. Spring brings flap adjustments and bark inspection. Summer requires cleaning debris from smoke holes. Fall preparation involves weatherproofing checks. Winter maintenance focuses on optimal heat retention settings. The basic system was remarkable, but master builders didn't stop there. They developed advanced variations for extreme weather, different clan sizes, and specialized purposes that showcase the true depth of Haudenosaunee architectural innovation. The basic longhouse ventilation system was incredible, but master builders didn't stop there. They created advanced variations that pushed their engineering to the absolute limits. Imagine maintaining 70 degrees Fahrenheit inside when it's minus 40 degrees Fahrenheit outside. With no electricity, no modern insulation, just brilliant traditional engineering. Picture winter in the Mohawk Valley, where snow piles 8 feet deep and winds howl for months. The Haudenosaunee looked at these brutal conditions and said, "We can beat this." They developed winter modifications so advanced that modern Arctic shelters copy their techniques. The double-layer bark system was winter engineering at its finest. Watch as builders install 2 complete bark coverings with a crucial air gap between them. The outer layer stops wind and precipitation. The inner layer controls moisture and provides a second thermal barrier. That trapped airspace works like the world's first insulation system. See how they calculated the perfect gap width, about 4 inches of dead airspace. Too narrow and heat transfers through. Too wide and air currents form that steal warmth. The builders tested these measurements over generations until they achieved the optimal thermal performance. Feel the intelligence in their snow load considerations. Winter longhouses needed roofs strong enough to support tons of snow without collapsing. The builders added extra support posts and strengthened the ridge beams. But here's the genius part. They positioned the supports to actually improve ventilation efficiency. Travel to the Great Lakes region, where lake-effect snow could dump 3 feet overnight. Here, the Haudenosaunee developed reinforced roof systems that turned snow into an advantage. Snow became additional insulation that improved the building's thermal performance. Watch the thermal regulation techniques that kept families comfortable during the harshest winters. Strategic fire placement created heating zones throughout the longhouse. Smoke hole adjustments balanced warmth retention with fresh air circulation. Bark flap positioning controlled both airflow and heat loss. The minimal heat loss protocols were masterpieces of energy conservation. Builders installed windscreens around entrances. They created airlocks using hanging bark or hide curtains. They positioned sleeping areas in the warmest zones and storage areas where cool temperatures actually helped preserve food. Now picture summer in the dense northeastern forests, where humidity can reach 90% and temperatures soar into the 90s. Mosquito clouds form moving walls of insects. Modern air conditioning struggles with these conditions, but the Haudenosaunee created natural cooling systems that worked perfectly. The summer cooling variations transformed longhouses into prehistoric air conditioning systems. Enhanced air circulation methods use strategic bark positioning to create cooling breezes throughout the interior spaces. Humidity control systems managed moisture without mechanical equipment. See how they created maximum pest barrier configurations for the bug-heavy summer months. Smoke patterns became precisely controlled insect repellent systems. Strategic fire positioning created overlapping zones where mosquitoes couldn't survive. Airflow patterns carried smoke to exactly the right places while keeping living areas comfortable. Watch the humidity control genius in action. Summer bark installations included specially positioned gaps that allowed moisture to escape while preventing rain entry. The builders understood that trapped humidity could make buildings unbearable, so they engineered natural dehumidification systems. Regional differences across Haudenosaunee territory showcase incredible adaptation skills. Mohawk Valley longhouses dealt with river valley climate patterns, heavy morning fogs, temperature inversions, and unique wind flows. Great Lakes adaptations handled lake effect weather, higher humidity, and different seasonal patterns. Travel to higher elevations where Seneca territory extended into hill country. Here, altitude considerations changed everything. Thinner air required different smoke hole calculations. Lower temperatures meant modified heating strategies. Wind patterns flowing over ridges demanded unique flap positioning techniques. See how forest-type influences drove construction variations. Dense hardwood forests provided different building materials than mixed forests. Coniferous areas offered different bark types and structural woods. Each ecosystem demanded adapted techniques. For ceremonial longhouses, the engineering challenges multiplied exponentially. Picture gatherings of 200+ people inside a single structure. That's the population of a small town, all needing fresh air, comfortable temperatures, and protection from smoke and pests. Watch the large-scale ventilation systems designed for these massive gatherings. Multiple smoke holes work together in coordinated patterns. Master builders calculated airflow for crowds, not just families. They designed acoustic systems that carried speakers' voices clearly throughout the enormous spaces. Feel the complexity of ritual fire management during ceremonies. Sacred fires burned in specific patterns for spiritual reasons, but the ventilation system still had to handle all that smoke and heat. The builders created systems that respected both spiritual requirements and physical comfort. See how ceremonial longhouses incorporated temporary expansion capabilities. Removable wall sections could increase capacity for special events. Additional smoke holes could be opened when needed. The entire building could transform from daily use to ceremonial configuration. Clan-specific customization showed how the same basic system adapted to different needs. Bear Clan longhouses might emphasize food preparation areas with enhanced cooking smoke management. Wolf Clan buildings might focus on craftwork areas requiring different lighting and ventilation patterns. Picture storage integration that worked with the ventilation system. Food storage areas needed different air circulation, enough to prevent spoilage but not so much that preserved foods dried out. Tool storage required moisture control to prevent rust and rot. Each family's needs influenced their section's air management. Watch multi-purpose space optimization in action. The same areas used for sleeping at night became workspaces during the day. Ventilation systems had to handle both functions perfectly. Smoke patterns that worked for evening fires needed adjustment for daytime cooking activities. Emergency configurations proved the system's incredible flexibility. When war threatened, longhouses could be modified rapidly for defense. When natural disasters struck, emergency shelters used the same principles, but with faster construction methods. See rapid deployment techniques that could create functional shelters in under 48 hours. Emergency longhouses use simplified versions of the full ventilation system. Fewer smoke holes, basic flap mechanisms, single-layer bark covering, but still effective climate control and pest protection. Watch wartime modifications that balance ventilation needs with defensive requirements. Smoke holes could be covered instantly to prevent detection. Ventilation flaps could close completely to stop light from escaping at night. The same system that provided comfort could also provide concealment. Picture temporary ventilation solutions for refugee situations. When entire villages needed emergency shelter, master builders could create connected longhouse complexes. Shared ventilation systems served multiple family groups while conserving materials and construction time. Travel through the seasons and see how one longhouse transformed its ventilation performance. Spring configurations handled wet conditions and temperature swings. Summer settings maximized cooling and pest control. Fall preparations optimized for food preservation activities. Winter modifications focused on heat retention and comfort. Feel the mechanical precision as builders adjusted hundreds of individual components. Each bark flap, every smoke hole cover, all the air gaps and openings, everything worked together like a giant natural machine. The same system managed smoke, pests, temperature, and humidity simultaneously. Watch the testing and calibration process for each new variation. Builders would monitor airflow patterns, test smoke management, observe pest control effectiveness, and measure temperature control. Any problems got fixed immediately through system adjustments. Modern military survival instructors study these emergency techniques because they work under extreme conditions. Special forces learn rapid longhouse construction for cold weather operations. Emergency response teams adapt the ventilation principles for disaster relief shelters. Picture contemporary applications of these advanced techniques. Eco-architects use ceremonial longhouse ventilation principles for large, sustainable buildings. Emergency management experts apply rapid deployment methods for humanitarian relief operations. See how the multi-purpose excellence inspired modern green building design. The same system controlling multiple environmental factors simultaneously, exactly what contemporary sustainable architecture tries to achieve with much more complex technology. The seasonal modification protocols show engineering that automatically adapted to changing conditions. Modern smart buildings use computerized systems to achieve what the Haudenosaunee accomplished through intelligent design and skilled craftsmanship. Think about the intellectual achievement these variations represent. The basic longhouse system was already remarkable, but creating specialized versions for different climates, purposes, and emergency situations, that required engineering genius that we're still trying to match. These advanced techniques weren't just historical curiosities. Modern experts have rediscovered these methods and are applying them in surprising ways across military, survival, and architectural fields today. Something amazing is happening in research labs, military training centers, and architecture firms around the world. Modern experts are rediscovering that 800-year-old Haudenosaunee techniques work better than many contemporary solutions. Picture a special forces training facility in Colorado, where elite soldiersers learn Arctic survival skills. The instructors don't start with high-tech equipment, they begin with traditional indigenous knowledge. Special forces now train using principles that Haudenosaunee builders perfected centuries ago. Watch military survival experts studying longhouse ventilation systems. They are learning how to create smokeless camps that can't be detected by enemy forces. They are mastering natural airflow techniques that work when modern equipment fails. The same principles that kept Haudenosaunee families comfortable now help special operations teams survive behind enemy lines. The US military's Arctic training programs specifically partner with indigenous communities to learn traditional survival techniques. Special forces instructors have discovered that ancestral knowledge often outperforms modern gear in extreme conditions. When lives depend on reliability, these ancient methods prove their worth. Feel the excitement in university research labs where scientists are testing traditional building techniques against modern systems. MIT researchers comparing longhouse ventilation to contemporary HVAC systems got results that shocked the engineering community. The traditional methods achieved better air quality with zero energy consumption. See how Dr. Sarah Chen at Stanford's Sustainable Architecture Lab measures airflow patterns in recreated longhouse models. Her team uses laser particle tracking to visualize how smoke moves through traditional ventilation systems. The efficiency numbers consistently exceed modern mechanical ventilation systems. Travel to the University of British Columbia, where Indigenous architecture researchers document traditional building techniques before they're lost forever. Professor James Winters explains, "These weren't primitive shelters, they were sophisticated climate control systems that we're still learning to understand." Scientific validation keeps confirming what the Haudenosaunee knew through practical experience. Laboratory testing shows their ventilation systems achieve optimal air exchange rates while maintaining thermal comfort. Computer simulations prove their designs create perfect pressure differentials for smoke management. Watch thermal imaging cameras reveal how longhouse ventilation systems manage heat distribution. The traditional designs create even temperature zones throughout the structure, while modern buildings often have hot and cold spots. Energy efficiency measurements show traditional systems using 60% less energy than comparable modern heating and cooling. Picture bushcraft instructors across North America teaching longhouse principles to wilderness survival students. Master instructor Tom Rodriguez from the Rocky Mountain Survival School says these techniques have saved more lives than any modern emergency equipment he knows. See how wilderness therapy programs incorporate traditional building methods into their healing approaches. Participants learn to create shelter using ancestral techniques while developing confidence and self-reliance. The process of building with traditional methods provides therapeutic benefits that modern construction can't match. Feel the hands-on learning as survival students construct miniature longhouse models to understand ventilation principles. They experiment with smoke hole positioning, test different bark covering techniques, and observe how airflow changes with different configurations. Contemporary eco-architects are revolutionizing sustainable building by applying traditional principles. The $2.3 million Ecosphere house in Vermont uses purely traditional ventilation techniques adapted for modern construction. No electric fans, no computerized controls, just intelligent design based on Haudenosaunee innovations. Watch architect Maria Gonzalez explain how her firm incorporates longhouse ventilation into luxury eco-homes. Our clients pay premium prices for what Indigenous builders accomplished with natural materials. We're not inventing new technology, we're rediscovering ancient wisdom. See the Breathe Easy house in Os, Oregon, where passive ventilation systems based on traditional techniques maintain perfect indoor air quality year-round. The building consumes 75% less energy than conventional homes while providing superior comfort and health benefits. Professional certification programs now teach traditional building techniques to licensed architects. The Natural Building Institute's advanced certification program includes modules on Indigenous ventilation systems. Architects pay $5,000 per course to learn what Haudenosaunee master builders knew by heart. Picture the Traditional Building Skills Academy, where construction professionals learn ancestral techniques that outperform modern methods. Students spend weeks mastering bark installation, smoke hole engineering, and natural airflow management. These courses have 6-month waiting lists because the demand is so high. Feel the excitement at professional conferences where architects share case studies of traditional technique integration. The American Institute of Architects now includes sessions on Indigenous building methods at their annual convention. Modern professionals recognize these aren't outdated practices, they're advanced solutions we forgot how to use. Research findings continue to validate traditional effectiveness across multiple performance metrics. Humidity control studies show longhouse ventilation systems naturally maintaining optimal moisture levels. Pest control research confirms that traditional smoke management creates effective insect barriers without toxic chemicals. Watch environmental impact studies comparing traditional versus modern building methods. The carbon footprint analysis shows traditional techniques producing 80% fewer emissions than contemporary construction. Material life cycle assessments prove bark and wood coverings outperform synthetic alternatives in sustainability metrics. See laboratory testing of traditional materials revealing properties that modern science is just beginning to understand. Elm bark's moisture management capabilities exceed many expensive modern building materials. Natural air filtration through traditional coverings provides cleaner indoor air than mechanical systems. NASA's Sustainable Systems Research Group studies traditional building principles for potential space habitat applications. The challenge of creating closed-loop life support systems in space mirrors the Haudenosaunee challenge of managing air, temperature, and humidity in harsh environments. Picture space habitat designers learning from longhouse ventilation principles. The same physics that moved smoke through traditional buildings could manage air circulation in Mars colonies. When humanity needs reliable life support systems for space exploration, we're studying techniques perfected on Earth centuries ago. Travel to the Biosphere, a research facility, where scientists test traditional ventilation concepts for sealed environment applications. The lessons learned from longhouse air management inform designs for sustainable lunar bases and deep space missions. Professional testimonials from experts across multiple fields confirm the practical value of traditional techniques. Military survival instructor Captain Mike Torres. In 20 years of teaching special forces, I've never seen methods more reliable than traditional Indigenous techniques. Feel the credibility as Dr. Amanda Foster, atmospheric physicist at NOAA, explains, traditional ventilation systems demonstrate principles of fluid dynamics that our computer models are still trying to perfectly replicate. The ancestral builders understood these concepts through empirical testing that spanned generations. See how emergency response coordinator Jennifer Walsh applies traditional principles in disaster relief. When hurricanes knock out power grids, these Ancient techniques keep people safe and comfortable. We're incorporating traditional shelter methods into our emergency preparedness protocols because they work when everything modern fails. Energy efficiency measurements consistently show traditional systems outperforming modern alternatives in specific applications. Comparative studies document 40% better thermal regulation, 50% improved air quality, and 90% lower energy consumption in properly designed traditional ventilation systems. Watch cost-benefit analyses that prove traditional techniques offer superior return on investment. Initial construction costs are 60% lower than modern HVAC systems, with virtually zero operating expenses and minimal maintenance requirements. Picture performance monitoring systems tracking traditional buildings over multiple seasons. The data shows consistent interior comfort levels regardless of external weather conditions. These systems automatically adjust to environmental changes without computerized controls or human intervention. Modern integration challenges drive innovation in adapting traditional techniques to contemporary construction requirements. Building code compliance issues get resolved through engineering analysis, proving traditional methods meet or exceed modern safety standards. See how contemporary fire safety requirements integrate with traditional smoke management systems. Modern fire suppressors and traditional ventilation work together, creating safer buildings than either system could achieve alone. Professional recognition of traditional knowledge continues growing across multiple disciplines. The International Association of Building Physics now includes traditional ventilation methods in their technical standards. Engineering schools add indigenous building techniques to their curricula. Feel the paradigm shift as modern experts acknowledge that traditional doesn't mean primitive. These techniques represent sophisticated engineering solutions developed through centuries of testing and refinement. The knowledge systems that created them rival anything produced by modern research institutions. Watch professional development seminars where established experts learn from traditional knowledge keepers. The transfer of ancestral wisdom to contemporary practitioners creates powerful hybrid approaches that combine the best of both worlds. Picture the future where traditional and modern techniques work together seamlessly. Smart building systems could incorporate traditional passive ventilation as primary climate control, with modern systems providing backup support only when needed. Understanding the science is one thing, but applying these techniques in modern contexts requires careful adaptation and practical knowledge. Here's your complete guide to implementing these ancestral innovations today. Ready to build your own longhouse ventilation system? Here's your complete guide to making it happen safely, legally, and effectively. Start with a 12-foot practice version in your backyard. It's the perfect way to learn, without major commitment or expense. Picture yourself walking through a modern hardware store with ancient wisdom in your head. You're not looking for complex HVAC equipment or expensive smart home systems. Instead, you're hunting for simple materials that can replicate what the Haudenosaunee accomplished with elm bark and wooden poles. Modern material adaptations make traditional techniques accessible to contemporary builders. Cedar shingles work beautifully as bark substitutes. They breathe like natural materials while meeting modern fire codes. Fiber cement panels provide excellent alternatives for exterior covering, with Class A fire resistance ratings. See how treated lumber replaces traditional posts while maintaining structural integrity. Pressure-treated 4x4 posts set in concrete foundations provide the stability of ancient tree anchors with modern durability. Galvanized steel brackets can replace traditional lashing, offering stronger connections that building inspectors will approve. Watch as you select materials for smoke hole covers. Heavy-duty canvas tarps with grommets work like traditional bark flaps. Marine-grade vinyl provides waterproof alternatives that still allow manual adjustment. Modern hardware stores carry everything you need. You just need to think like an ancient engineer. Fire safety considerations must be your top priority when adapting traditional techniques. Modern fire codes require spark arresters on any smoke openings. Install commercial chimney caps designed for wood-burning stoves over your smoke holes. These meet safety requirements while maintaining the traditional airflow principles. Feel the importance of proper clearances around fire areas. Building codes typically require 18 inches of non-combustible material around any fire source. Use fire bricks, concrete pavers, or metal sheets to create safe fire zones inside your traditional structure. See how smoke detectors integrate with traditional ventilation systems. Battery-powered units work perfectly since they don't interfere with the natural airflow patterns. Place detectors away from smoke holes to prevent false alarms while maintaining safety coverage. Building code compliance strategies turn traditional techniques into legal construction methods. Many jurisdictions have alternative building provisions that allow traditional methods if properly engineered. Contact your local building department early in the planning process to discuss approval pathways. Picture meeting with a building inspector who is curious about your unusual project. Come prepared with engineering calculations showing structural loads, ventilation rates, and fire safety measures. Many inspectors appreciate innovative approaches when they see proper planning and safety considerations. Watch how professional engineers can stamp plans that incorporate traditional techniques. Structural engineers familiar with timber framing often understand traditional building principles. Their approval makes permit applications much smoother and demonstrates professional oversight of your project. Progressive skill development prevents costly mistakes and builds confidence systematically. Master these 3 fundamental techniques before attempting larger projects: proper post spacing, accurate smoke hole sizing, and effective flap adjustment systems. See how beginner-level projects teach essential skills. Start with a simple 8x12 foot shelter using modern materials. This size lets you experiment with ventilation principles without major expense. Total materials cost under $300. Feel the learning process as you build your first smoke management system. Install a single smoke hole with adjustable cover above a small fire area. Test different flap positions and observe how airflow changes with the various adjustments. This hands-on experience is worth more than any theoretical knowledge. Watch intermediate projects expand your capabilities. A 12x16 foot structure with 2 smoke holes teaches coordination between multiple ventilation points. Materials cost increases to around $600, but you gain valuable experience with system integration. Advanced large-scale projects require serious planning and substantial investment. Full-size longhouse replicas need professional engineering, proper permits, and significant budgets. Expect costs between $15,000 to $30,000 for a complete traditional structure meeting modern codes. Picture the equipment and tools needed for serious construction. Traditional building used only hand tools, but modern safety and efficiency suggest power tool adaptations. Circular, saws, cordless drills, and pneumatic nail guns speed construction while maintaining traditional joinery principles. See the specialized equipment that improves traditional techniques. Laser levels ensure accurate post-positioning that ancient builders achieved through skilled craftsmanship. Modern measuring tools prevent the errors that required generations of experience to avoid. Feel the value of quality hand tools for detailed work. Traditional bark harvesting techniques work best with sharp draw knives and specialized peeling tools. Invest in professional-grade woodworking tools. They last decades and improve your results dramatically. Legal and ethical guidelines protect both you and traditional knowledge holders. Check local zoning laws before starting any construction project. Some areas restrict alternative building methods, while others encourage innovative approaches. Watch the permit application process unfold step by step. Residential permits typically cost $200 to $800 depending on project size and location. Commercial permits for larger structures can reach $2,000 to $5,000, but provide legal protection for your investment. See how land use considerations affect project planning. Rural areas often have more flexibility for alternative construction, while urban zones may restrict traditional methods. Research your specific location's regulations before purchasing materials or starting construction. Cultural sensitivity protocols ensure respectful use of traditional knowledge. Always acknowledge Haudenosaunee origins when sharing your project with others. Consider donating a portion of any commercial application profits to Indigenous education programs. Picture yourself consulting with local Indigenous communities about your project. Many tribal cultural centers offer guidance on respectful use of traditional techniques. This consultation demonstrates proper respect while potentially providing valuable technical insights. Feel the importance of accurate attribution when teaching others. Never claim to have invented techniques that Indigenous peoples developed over centuries. Proper acknowledgement honors the knowledge creators while building bridges between traditional and contemporary building communities. Troubleshooting common issues saves time, money, and frustration during construction and operation. Smoke management problems usually stem from incorrect hole sizing or improper flap adjustment. Start troubleshooting by checking these basic parameters. See how smoke backing up into living areas indicates insufficient draft or blocked openings. Clean debris from smoke holes seasonally. just like modern chimney maintenance. Leaves, snow, and bird nests can block critical airflow paths. Watch for signs of inadequate ventilation, lingering smoke odours, moisture buildup, or uncomfortable indoor temperatures. These symptoms suggest system imbalances that need immediate attention. Adjust flap position systematically, testing each configuration before making further changes. Seasonal adjustment difficulties often surprise new practitioners. Summer and winter require completely different ventilation configurations. Document your successful settings for each season to speed future adjustments. Feel the learning curve as you master system maintenance. Traditional buildings require active management, not passive operation like modern HVAC systems. Plan to spend 2 to 3 hours monthly on system adjustments and maintenance during your first year of operation. Picture common maintenance requirements throughout the year. Spring brings cleaning debris from winter storms. Summer requires maximum ventilation configuration. Fall preparation involves weatherproofing checks. Winter focuses on optimal heat retention settings. Cost reality check. Building a functional traditional ventilation system for under $500 is absolutely achievable. This budget covers materials for a basic 8 by 12 foot structure using modern equivalents of traditional materials. See the detailed budget breakdown. Pressure-treated lumber for framing $150, cedar shingles for covering $200, hardware and fasteners $75, fire safety materials $50, ventilation components $25. This total provides everything needed for a complete learning project. Watch how costs scale with project size and complexity. Double the dimensions, and material costs triple due to structural requirements. A 16 by 24 foot structure typically costs $1,200 to $1,500 in materials, while professional installation adds $2,000 to $4,000. Timeline expectations help plan realistic project schedules. Basic skills development takes 6 to 12 months of regular practice. Intermediate proficiency requires 1 to 2 years of hands-on experience. Advanced mastery typically takes 3 to 5 years of serious study and practice. Picture community workshop opportunities that accelerate learning. Natural building groups often welcome newcomers to collaborative projects. Participating in group builds provides mentorship, shared costs, and valuable networking with experienced practitioners. See how professional training programs structure skill development. Week-long intensive workshops cost $500 to $1,500 but provide months of equivalent learning. Online courses offer flexible scheduling at $100 to $500, though hands-on practice remains essential. Integration challenges require creative solutions when adapting traditional techniques to modern requirements. Building inspectors may need education about traditional methods. Prepare documentation showing historical precedents and modern safety adaptations. Feel the satisfaction as your traditional ventilation system passes its first winter test. Watching smoke rise cleanly through your handcrafted openings while staying warm and comfortable connects you directly to centuries of ancestral wisdom. Watch friends and neighbours discover the effectiveness of your traditional climate control system. Modern people often express amazement that ancient techniques work better than contemporary alternatives. Their reactions validate your learning investment. Picture the pride of creating functional art that serves daily needs while honouring traditional knowledge. Your longhouse ventilation system becomes both practical shelter and cultural bridge, connecting past wisdom with present needs. Success indicators confirm your system works correctly. Clean air above head level during fires, comfortable temperatures without mechanical heating or cooling, and natural pest control without chemicals all demonstrate proper function. See how your skills transfer to other traditional building applications. Mastering longhouse ventilation principles enables understanding of other indigenous architectural innovations. This knowledge foundation supports lifelong learning in traditional building arts. While these techniques can be incredibly effective, it's crucial that we approach this traditional knowledge with the respect and cultural sensitivity it deserves. Here's how to honour the Haudenosaunee legacy while learning from their innovations. Before we implement any traditional technique, we must address the elephant in the room: cultural appropriation versus cultural appreciation. The longhouse ventilation system we've explored isn't just ancient engineering, it's sacred knowledge passed down through generations of Haudenosaunee people who faced centuries of cultural suppression. The Haudenosaunee Confederacy, comprising the Mohawk, Oneida, Onondaga, Cayuga, Seneca, and Tuscarora nations, has maintained these traditions despite systematic attempts to erase their culture. When we learn from their innovations, we have a responsibility to honor their ongoing stewardship of this knowledge. This isn't just technique, it's sacred knowledge passed down through 900 years of indigenous innovation. Proper cultural attribution means more than a simple acknowledgement. It requires understanding that traditional ecological knowledge represents generations of careful observation, experimentation, and refinement. The Haudenosaunee developed these systems through intimate relationships with their environment, relationships that continue today. The difference between appropriation and appreciation lies in reciprocity. Cultural appropriation takes without giving back, profits without permission, and simplifies without understanding. Cultural appreciation acknowledges sources, supports communities, and seeks ongoing relationships rather than one-time extraction. How $10 can help preserve 1,000 years of wisdom, and why that matters for everyone's future. When we apply Longhouse ventilation principles, we should simultaneously support Haudenosaunee cultural preservation efforts. Organizations like the Six Nations Iroquois Cultural Center in Oneonta, New York, and the Iroquois Indian Museum in Howes Cave work tirelessly to maintain traditional knowledge systems. These institutions face constant funding challenges while preserving knowledge that could benefit all humanity. A $10 donation to the Indigenous Education Institute supports language preservation programs. $25 funds traditional skills workshops that keep these techniques alive for future generations. The Haudenosaunee have never stopped innovating. Today's Indigenous architects and engineers blend ancient wisdom with contemporary materials, creating buildings that honor tradition while meeting modern building codes. Their work proves that traditional knowledge isn't museum pieces, it's living, evolving wisdom. Indigenous communities are leading climate solutions. Here's how traditional knowledge saves modern buildings. Supporting cultural preservation also means recognizing contemporary Haudenosaunee contributions to architecture, environmental science, and sustainable technology. The Haudenosaunee Environmental Task Force has pioneered renewable energy projects that incorporate traditional ecological principles. When businesses and institutions adopt traditional techniques, they should establish formal relationships with Haudenosaunee communities. This might involve consulting fees for knowledge keepers, partnerships with tribal colleges, or percentage-based giving programs that support cultural education. The secret ingredient that makes traditional knowledge work? Relationships, not just techniques. Ethical implementation requires ongoing relationship building, not one-time learning. The Longhouse ventilation system works because it emerged from deep relationships with specific environments, materials, and communities. Respectful adoption means understanding these relationships, not just copying techniques. Educational institutions should partner with Haudenosaunee cultural centres to ensure accurate representation of traditional knowledge. The Woodland Cultural Centre in Ontario offers educator training programs that help teachers present Indigenous knowledge respectfully and accurately. Many Haudenosaunee communities offer cultural consultation services for architects, builders, and educators interested in incorporating traditional knowledge. These relationships ensure proper attribution while providing economic support for cultural preservation efforts. Why the most important lesson isn't about ventilation, it's about respect. Remember that longhouses aren't just buildings, they're sacred spaces with spiritual significance. While we can apply ventilation principles respectfully, we must never appropriate ceremonial or sacred elements. The techniques we've discussed represent the practical, shareable aspects of longhouse design. Respectful application means adapting principles rather than copying forms. Your modern building can benefit from longhouse ventilation wisdom without looking like a longhouse. Innovation honors tradition when it grows from understanding rather than imitation. The Haudenosaunee concept of 7-generation thinking, considering the impact of today's decisions on 7 generations in the future, should guide our use of traditional knowledge. How will our applications affect Indigenous communities 7 generations from now? 7-generation thinking, the Indigenous principle that could save our planet's future. Cultural preservation isn't just about the past. It's about ensuring that traditional knowledge continues evolving through Indigenous communities, rather than being frozen in non-Indigenous interpretations. Support the knowledge keepers, learn from the source, and build relationships that honor both tradition and innovation. By approaching traditional knowledge with respect, reciprocity, and relationship building, we ensure that ancient wisdom continues flourishing while serving contemporary needs. The Longhouse ventilation system teaches us about more than airflow, It teaches us about living in right relationship with knowledge, community, and environment. You've just experienced 900 years of Haudenosaunee innovation. But knowledge without action is just entertainment. Here's how to transform everything you've learned into real-world applications that could change your life, your community, and maybe even your career. Start with these 3 steps before this video ends. No experience required. Step 1. Document your local climate challenges. Spend this week observing airflow problems in your space. Hotspots, cold drafts, humidity issues. The Haudenosaunee solved all of these. Your modern solutions start with ancient observation skills. Step 2. Connect with your nearest Indigenous cultural centre. The Woodland Cultural Centre in Ontario offers educator workshops. The Iroquois Museum in New York provides hands-on experiences. These institutions don't just preserve knowledge, they're actively teaching it to respectful learners. Step 3. Join the online traditional building community. The Natural Building Network connects 50,000 plus builders worldwide. Share your observations, ask questions, find local mentors who have successfully integrated Indigenous techniques into modern projects. Find your local traditional buildings group today. Here's where to look. Your local makerspace likely has members interested in sustainable building. Search Natural Building Workshops plus your city name. The Traditional Building Skills Institute runs programs nationwide. Historic England's Heritage Skills Programme offers intensive 6-month fellowships for serious practitioners. University extension programs increasingly include traditional knowledge courses. The Indigenous Society of Architecture, Planning and Design connects learners with Indigenous practitioners. These aren't just hobby groups, they're launching careers in sustainable architecture. Master these techniques in 6 months with this proven progression plan. Month 1 to 2. Material familiarity and basic construction principles. Practice with small-scale models. Understand thermal dynamics and airflow patterns. Month 3 to 4. Begin actual construction projects. Build your first functional ventilation system. Connect with local workshops for hands-on experience. Month 5 to 6. Advanced applications and regional adaptations. Integrate traditional principles with modern building codes. Develop your signature style. Historic England's research shows this timeline produces competent practitioners ready for professional applications. The Centre for Employment Training reports 85% job placement rates for their 8 to 9 month green building programs. 330 retention hook. Next week, Pueblo Adobe climate control secrets that outperform modern HVAC. The applications are limitless. Emergency management agencies now incorporate traditional shelter principles into disaster response training. Eco-architecture firms seek builders with Indigenous knowledge backgrounds. Military survival programs pay premium rates for instructors with traditional skills. The Earthship Biotecture Academy reports growing demand for traditional knowledge specialists. Sustainable architecture programs actively recruit students with cultural competency in Indigenous building techniques. But here's what matters most. You're now part of a community preserving human ingenuity. Every structure you build using Haudenosaunee principles honors their innovation while solving contemporary problems. Subscribe to Heritage Hacks for more ancestral wisdom that outperforms modern solutions. Next week, we're exploring Pueblo Adobe techniques that maintain perfect indoor temperatures without electricity. The week after, Viking longboat engineering that's revolutionizing modern yacht design. Share your projects in the comments. Tag friends who need these skills. Join our Discord server for ongoing support and collaboration opportunities. The Haudenosaunee didn't just build shelters. They created architectural innovations that remain unmatched after 800 years. By learning their techniques, you're not just gaining practical skills, you're becoming a guardian of human ingenuity and ensuring that this remarkable knowledge continues to benefit future generations. The ancestors solved problems we're still struggling with. Isn't it time we started listening? Your journey into ancestral wisdom starts now. The knowledge is waiting. The community is ready. The only question is, are you?